The only thing this guy does is gives me what? For the
Z-score.
Gives me hives. No, it gives me the Z-score, and it's done. You guys with me? So the level of confidence I want does that one thing, and then forget about it. What's the percentage I see from my sample? How do I calculate that?
68 divided by 80.
Yes! 68 divided by 8. And then somebody help me out.
0.85.
Sounds alright. So what's Q hat? I'll do it for you. I don't care what clothing they're wearing, P and Q have to add to be 1. So P shoe plus Q shoe. There is no P shoe, by the way. Thought I know one.
No, I was asking a question.
Okay, I love it. You guys are awesome. Answer your own question. Yes.
So you know how like the other PQ problems you have like 2 percentages, but like the one that's P is always the success?
Oh, I see what you mean.
How do you know which one to calculate?
Well, if I were to finish that question out, for the true percentage of parents who decorated,
Oh.
and 68 decorated, they match. So the same thing before, the success has to be what the question is looking for. So that's a good point, but it's not gonna happen. That would be really evil. I'm not quite there yet, no matter what you think. I'm not quite evil yet. Now, I can check to see if this is normal enough. I don't have P or Q. P is the percentage of the population. So what I use when I don't have that, I just use the next best thing, P hat. In fact, the whole point of this problem is I don't know what the percentage of all parents is that decorated for Halloween. I'm trying to figure out an interval for it, right? So I don't know P. I got to use the next best thing, P hat. Some of you guys, okay. What is 80?
People,
What letter would it go with it? What letter? What variable?
And
N. So what's N times P hat? Now if you don't trust me, what am I doing right now? I'm checking these, right? To make sure I could do anything with this. If you don't trust me, what is 80 times 0.85?
68.
Of course it freaking is, because I divided 68 by 80 to get 0.85. So there's a little shortcut for checking for normality. NP hat will always equal the number of successes. If you don't like what I just said, just do the math. You'll catch up.
Is it the same for N and P as well?
Yeah, and again, P hat is P. It's just in this case, it's a sample. That's all I got.
But what if we have both in one problem?
Then you would use this, and it wouldn't be a confidence interval then, because confidence intervals are constructing an interval to catch P, and if I know P, there's no point to this question. So you would never have both in this kind of question. I like it. We're not done yet, right? What's good about that 68? It's what? It's at least 5. Yes? What do I still have to check? Now I know it's going to be 12 because that's 12 people are failures, right? If you don't trust me again, you can do 80 times 0.15 and then you're going to get 12. I mean, either way you do it, you'll catch up to it. So those are both, so it's exactly the same as that n greater than 30 step. It's just a little bit longer. These are percentages, they're a little bit freakier. I got 2 things to check instead of 1, but it accomplishes the same thing that n greater than 30 does. What can I say now? The distribution I'm working with is normal enough. Right? So the real problem is if you never really understood n greater than 30. That sucks because I'm building right on top of that. If you understand n greater than 30, this just takes that place. When do I do this thing? When I have percentages, because there's percentages in this one. Right? I like it. I like it. Okay, I see a few light bulbs. No, I love, there's a certain sound or look that I'm like, okay, good, yeah. You guys haven't made that sound or made that look yet, but we'll get there. All right, so now that step just tells me I can do something. All right, let me stop for a minute. You guys, everybody okay?
So you still don't have the answer?
No.
No, hell no. Have I made an interval yet? No. Aw, and again, I love you guys so much. Why is this problem taking so long? How many of these kind of problems have we done? None. We're in the middle of the first one. So doesn't the first time we do a problem involve a lot of Jeff talking? God, Jeff talks a lot all the flipping time, right? So this is not an accurate representation of how long this problem should take. What have we done so far? Barely shit, right? We calculated these, and we multiplied those and saw they were at least 5. So if we were just doing the problem straight, that would have been less than a minute. Okay. Yes?
What if it's not normal
Then you can't do shit. I love it. If they don't say it's normal, that it came from a normal population, you can't do anything. That would be stats 2. Yes?
Oh, never mind. Are you ever gonna do that?
That would be great. Someday I'm going to take a sabbatical, some semester. You guys know what a sabbatical is? I was going to tell you, a student actually called and said, is he on sporadical? That's too awesome. I have never taken a sabbatical, but a sabbatical is a paid semester where a teacher has to put in an application with all the research they want to do, and I want to create a couple courses. So I might put in an application to get a semester off, and then I want to kind of like travel and create a history of math course and a stats 2 course. So maybe someday. So it's not going to help you out anytime soon, sorry. And the rest of you guys are like, dude, I don't even like stats 1. What do you know? Okay. So, do we have, 90% confidence? Can somebody help me figure out what that z-score is? I showed you guys the little baby chart, right?
1.645.
Oh, yeah.
Little baby chart down here. 1.645, yes. So we have everything we need. Let me take this away for a second, so I can put it right underneath here. P hat, 0.85, give or take, 1.645, this many, I don't need that, of these. Where did it go? 8. So the next level of thing to be careful about is putting this in your calculator correctly. Let's look at that.
Is that the error?
This piece will be the error, and that's a good thing to figure out first. Yes? It doesn't matter, right? As long as you put the bigger one over here and the smaller one over there. You have to do 2, right? Because plus or minus entails 2 calculations. Yeah. Yes.
So what if the z-score is not 90 since you said that you're not going to give us one that is on the little...
Oh, hell yeah, I am. You know I am. I'll ask you to make a 93% confidence interval. Huh?
Are we going to learn?
Oh, we desperately should know how to. In fact, that's how we did some of the X-bar confidence intervals, right? Yeah, you do 90. If I wanted 93%, 93%, what's outside then? How much? 7%. So what's on that side? 7. 7. Cut it in half. Half of 7. 3.5%. 0.035. I would look that up in the chart. You guys remember that? You know I'm going to do that because I'm that much evil. Yes.
Right now we're looking at the z-score for what, just 90?
90, yes. 90. I'm sorry, I took it away, but it was a 90% that I wanted, right? So, now watch. Now, hey, careful. Let me catch you right there. If you look up 0.9, you're going to get a z-score that has 90% below it. That is not the 90% confidence interval. 90% confidence interval has 90% in it. right? Don't forget stuff we know. 90% inside, how much is outside?
Oh.
10%, how much on this side? If you look up 0.05. Oh crap. Enhance. 0.05, look, see? Oh shit, follow that stuff. 1.645. Right? So, what just happened with those two questions are, there's a shortcut for the most commonly used things. Coffee stains not included. But I gotta make sure you remember how to do it this way, because this is old news. This is chapter 6 stuff here. We have to know how to create any confidence interval your crazy ass teacher wants you to make. Right? Alright, so help me out. Anybody do this part yet? Anybody need to borrow a calculator? You're gonna need one. 0.65?
0.066.
Yeah, I get, 0.066. Kick ass. If you have the older calculator where it has a square root symbol and then a parenthesis, you don't want to close that parenthesis until you get everything in. The newer calculator, you can actually see the square root grow. That's kind of nice. And that was just this piece here. Right, that's just doing this piece here. And then I'm going to subtract that and add that. I don't know, did I show you this little dude? This is not that big of a shortcut, but if you store your answer in X, you can then do 0.85 minus that, 0.85 plus that.
How do you store it?
Your store right there. Yeah, the store thing is nice though, because then you just have one letter to bam bam. Yeah, there's a lot of different ways you can do it. And you don't have to do that shit at all. You can just do 0.85 minus 0.066, 0.85 plus 0.066. Yeah, let's see. I didn't really save that much time, did I? But still, it's a little thing. So what's my interval? My interval goes from 0.784 up to 0.916. Now, in general, I want P hat and Q hat and all this stuff out to at least 3 places. You can make it 4 to match with the other percentages we did before, right? If you want to, it's up to you. This one just happened to have just 2 places. That's why it didn't come up. It just naturally came out to be that. How do I write the conclusion? We are 90% confident that the interval, I always want units. These are percentages. Change them into percentages. That's the units. So the interval what?
0.7.
No. What did I just say? 78.4% to 91.6% contains what?
The true.
No. True.
Percent.
True percentage of parents that decorated for Halloween already.
Are you gonna have to write?
Yes.
For each problem?
Yes.
Yes.
Are you gonna mark this down if you just like a specific part of the sentence?
I don't want you to memorize the words in the sentence, but what's important here, this is a very minute detail, but it actually is really kind of important. I can't say that I'm 90% confident that the true percentage is between these two. That sounds like the same thing I said. Does anybody agree? I just said two different things. What I have written up here is correct. If you say we're 90% confident that the true percentage is between these two things, you're wrong. Just because. No, it's because of this. The true percentage is something, right? What's the percentage of parents that have decorated? There is a number that is the percentage of parents that have decorated. Everybody agree with me, right? That wasn't a command, it was more of a question. Everybody agree with me. When I construct an interval, there is a chance that my interval catches the real percentage. If you say it the other way around, it sounds like I make an interval and then this falls somewhere. Maybe in it, maybe out of it. But that's not true. It is a number. It exists. There's a chance my interval contains it. That's the correct way to say it. That matches what really is happening. If you don't quite get what I'm saying, then maybe you can memorize this. But you know, I always want it to make sense, not just something to memorize. So we are such and such confident that the interval we made contains the true percentage. Because again, like I did last time, somebody else could come along and make their own interval, and they just happened to pick a sample that was so far below this that they actually don't contain the real percentage. Will they know that? No, never. They'll never know that. That's why this. What's the chance what percentage of intervals that a lot of people could make won't contain it? Won't contain the true percentage. What percentage of intervals won't contain the true percentage? 10%. And there's a thing I'm probably going to have to do, well, I don't know if we're going to make it there today, then I'm going to have everybody create their own interval from some data I give you, and then we'll see concretely what percentage didn't catch the real mean. So we'll see. And again, it's all probability, so I could be way off. So every time I do that, I'm like, let's find out. But with this many people, I feel pretty good. It's going to work out pretty well. Okay. All right, so on the other side of that handout, the one side says dolphin stuff, right? The other side is section 8.3. Go ahead and do that side. Sure. Uh-oh.